Okay, yesterday we talked about finding vertical asymptotes. Today we need to talk about finding horizontal asymptotes. We got to do a little bit of thinking before we start, though. I know, but you can do it. Okay? So far in basketball season, during games, Charlie has shot 30 free throws. Unfortunately, she has only made 13 of them. Up to this point, what's her stat for percent of free throws made? Any idea? Any idea how we would even do that? Divide 13 by 30? What do you get when you divide 13 by 30? So if we say 13 divided by 30, and somebody said that's 0.43333, like repeating, right? What percent is that? Because it's asking for the percent, right? So 43.3%. Okay, and how do we get that? Multiply that by 100. Okay. After such a poor start, Charlie gets some advice from the coaches and practices daily. If she does not miss another free throw for the remainder of the basketball season, how many consecutive free throws will she need before she makes her percentage reach 80%, 90%, and 100%? Okay, so right now she's at 13 over 30, which is 0.433, and her percent is 43.3%, correct? So what about if she makes one more free throw? Then she is 14 for 31, right? Well, what's her decimal then? 0.451, which makes her percent 45.1%. Okay. What if she makes another one? What's her fraction? 15 out of 32. What's the decimal? 0.469. Okay. So 46.9%. What if she makes another one? 16 out of 33. 0.485. So 48.5%. What if she makes another one? 17 out of 34. And her decimal is 0.5? Oh yeah, it's half, right? So 50%. What about 5? 18 out of 35. 0.514. You're doing this, right? 51.4%. What about if she makes 10? 20 what? 23 over 40, right? It's actually 5 more than this one, so we're just adding 5 to each of these, right? Or we're starting for the very beginning and adding 10 to each of these, correct? What decimal is this? 0.575, so 57.5%. What about 20? 33 over 50. I'm just going to say 0.6 repeating. So that's 66%. Oh, not really though, right? 67 if we're going to do that. Okay, what about 50? 63 over 80. 0.788%. So, or sorry, decimal. So 78.8%. What about 100? So 0.869. So 86.9%. What about if she makes X more free throws? X plus 13 over X plus 30. Okay? So after how many consecutive free throws will her percentage reach 80%? Oh, time out. I missed this over here. Sketch of the graph of this relationship in the given window. So put this in your calculator and y equals and go see what the graph looks like. Something like that, right? Because I really only care about the first quadrant, right? I know there's more to this graph because I know what a parent function of a rational function looks like. I know there's more to it, but I'm only caring about first quadrant because I'm only caring about positive numbers right now, correct? Okay? So what equation relates these two quantities? If we're talking about consecutive free throws made and then percentage made, does this give me the percentage? What gives me the percentage? What do I have to do to this to get the percentage? Times it by 100? Right? So after how many consecutive free throws does she get 80%? And how are you figuring it out? So you're looking at the table. So when does it get to 80%? When y equals what? So on y, what are you looking for on the table? When y equals what? 0.8. Okay. So 55. So at 55 free throws, whoops, she is at 80%. When does she reach 90%? When will she reach 100 free throws? 100%. What do you mean never? Surely it'll get close enough to get to 100. So it'll eventually get to where you can round to 100. And if you really want to get technical, your calculator can't even handle it, and it gets to 100. Okay? We're smarter than the calculators, though, and we know that since she missed some at the beginning, she can never get to 100%. Okay? Any questions about that? So, often when using rational functions, when you plug in larger and larger numbers for x, the answers for y keeps getting closer and closer to a certain value. This value is called a limit. Okay, Mrs. Clower will be very happy that we talked about limits in Algebra 2. We're approaching a certain number. We're approaching a limit. Okay? So in the basketball program, what was the limit on her percentage? 100%. Graphically, this makes an asymptote, doesn't it? What kind? Because like if we're looking at it on this graph, isn't it right here? Right? Okay. So, put this in y equals x minus 4 over x minus 2. And Chandler and I figured out some a second ago. Okay? When you go to the y equals, when you tab to get your equation line, put in parentheses x minus 4, close parentheses, then divide by x minus 2. All in parentheses. That denominator's in parentheses. When you hit enter, it will pop up looking like this. Okay? Don't just try to put a parenthesis here and here because it's not going to do the right thing. Okay? Or you could use the fraction button. Absolutely. Absolutely. Where is that, Lucas? Above the division sign? So you can use control and then the fraction key. Okay? If you don't want to deal with parentheses, just use that. Okay? So when this is true, or when this is our equation, what is it when x is 1,000? Remember how to change how your table counts? The table step. So I'd go by thousands. So you don't have to keep like scrolling everywhere. .99 what? So 8. So what is it at 2,000? .999. What is it at 3,000? .9993. What is it at 4,000? 9995. .995. Okay, so where do you think this is approaching? Where do you think this is going? What's the horizontal asymptote? Where is it going though? Yeah, so which variable is going to 1? The y. Is it ever going to get to 1? And that's how I know there's an asymptote there. Okay? So I want you to finish these right here. Okay? These 7 right here, and then this question right here at the bottom. Your substitute is about to put a filled in one of these charts that she or he already gave you. Your substitute is about to put one of these up on the board for you to copy, a completed one, so that you have all these notes. Okay? But this worksheet right here is going to answer this question at the bottom. So I want you to think about this before you just start copying the one that the substitute will put up for you in just a moment. Okay? Do you have any questions? Okay. I hope you have a great day.